sometimes the question is not interested in the whole of the circumference, but interested in a part of circumference. This part of circumference is known as the arc. So let's see what an arc is. So if we have a circle and we are interested in a part of the circumference, so let's say we are interested from this point A to this point B. So the question wants us to find out what is this length. This is known as the arc, and the arc is denoted by this symbol of a curve. So to find out the length of the arc, we should know the formula. The length of the arc is given by the formula theta over 360 into 2 pi r. So from here you got to know why is this known as the part of the circumference, because it is a fixed ratio of the circumference. But here we got to know something as theta. What is this theta? So let's understand this. Theta is the angle that this arc makes at the center of the circle. So that's theta. So for example, let's say if we look at a question which says, what is the length of the arc AB if the central angle is 20 degrees and the radius is equal to 4. So to solve this question, we would directly use this formula. The question says that the angle is 20, so we have 20 over a 360 into 2 pi r. So this becomes a 1 by 8 into a 1 by 18 into an 8 pi. So this becomes a 4 by 9 pi. And similarly, this area AOB is known as the sector of the circle. So we have something known as a sector. So let's see what this sector is. The sector of a circle is this part A O B. So sometimes the question is interested in the perimeter of the sector. So sometimes the question would ask the perimeter of the sector, which is not given by theta by 360 into 2 pi r, because that just gives us this. The perimeter of the sector, if you look at it carefully, includes the arc AB plus the length of the radius OA plus the length of the radius OB, which in this case of the last question becomes a 4 pi by 9 plus a 4 plus a 4, which is 4 pi plus 36 plus 36 by 9, which is a 72 plus 4 pi by 9. So that's the total perimeter of the sector that we have here, which is AOB. Now the question can also ask you for the area of the sector. So we may have a question which talks about the area of the sector AOB. So let's say if we have the perimeter of the sector as AOB and this angle is 20 degrees, the question may be interested in the area of the sector. The area of the sector is given by theta over 360 into a pi r square. And if we take the example as the radius as 4, then the area here would be 20 over 360 into pi 4 squared, which becomes a 1 by 18 into a 16 pi, or we get an 8 pi by 9. So that's the area of the sector here. Now let's look at the last few things to be kept in mind. So we are interested in a few things to be kept in mind about circles. A few things that we should keep in mind about circles. First is, if there's an arc which makes an angle theta at the center of the circle, if there's an arc which makes an angle theta at the center of the circle, then the same arc would make an angle theta by 2 on the circumference of the circle. So I repeat, if there's an arc AB which makes an angle theta at the center of the circle, then the same arc would make an angle theta by 2 at the circumference of the circle. The second point which we have to keep in mind is, the second point that we should keep in mind about the circles is, if we make an angle in the semicircle, if we make an angle in the semicircle, it would always be a right angle triangle. So that means if we make a triangle inside a circle with one of its sides as the diameter, it would always be a right angle triangle. So wherever we make a triangle in this figure, it would always turn out to be a right angle triangle. Keep these two things in mind to answer a few questions better and faster on circles.